Okay, so we again are going to start on page 9 for today. Last time when we were working through our practice problems, we skipped number 3 on page 9 because we hadn't talked about that type of question yet. But you watched your notes last night where we discussed the inference portion of the sampling, inferences, and conclusion stuff. So now we have the tools that we need to be able to talk about a problem like number 3. So as I look at number 3, okay, I want to read through the information I've got here. Remember, we want to be really careful about not saying that one thing caused another thing. A relationship that I noticed is not the same thing as this made this other thing happen. That is not the same. The best example of that I can give you is on Friday. My son was first in line at the bus stop. He was first one on the bus. It's a big deal. They fight over who gets to be first in line. So he was first in line on the bus. At recess on Friday, in his words, he drank 80 pounds of water. And then what do you think happened next? Other end. He threw up, right? Because if you drink a bunch of water and then run around, you don't feel good and you get sick. So now in his mind, if you are first in line at the bus stop, you are going to throw up at recess. Okay? Were those two things that happened on the same day? Yes. Did being first in line at the bus stop make him throw up at recess? No. Can I definitively say that drinking 80 pounds of water is the thing that made him throw up at recess? Maybe not, but I would argue that there's a stronger relationship there based on like all of our own collective past experiences. If I drink a bunch of water really fast and then run around, like bad things can happen. So remember, correlation is not causation, okay? First in line at the bus stop does not mean that you are going to throw up at recess. Coincidentally, he has insisted on not being first in line at the bus stop the last couple of days. He has also not thrown up at recess, which is his point. But anyway, correlation, not causation. Does that make sense? Okay, silly example, but it kind of gets our point across. So correlation not equal to causation. And then the other thing to look out for is who I like observed or did my experiment on, or who I surveyed, versus who I am making statements about. If I only talk to high school freshmen, I can only say things about high school freshmen. Okay, so those are the two big ones that I want you to keep in mind as we go through our practice problems for today. So for number 3, it says Melissa is in the 7th grade. She wanted to know how after-school activities are done on the week before an exam affects the score of the exam. So what you do after school before you have a test, does that impact how well you do on the test? She asked all of her classmates to record their after-school activities on the week before a big exam. Later, she compared the records with the achieved scores of each student. After analyzing her results, Melissa found a positive linear association between the amount of time spent reading books and the achieved score on the exam. Which of the following describes valid conclusions that can be made from the results? Okay, so let's take a look at each of these. Let's pick these all apart. So our first one says the results suggest that there's a positive correlation. First off, I like that it says positive correlation and not one thing causes another thing. So that's a point in favor of this first one. Let's keep reading. Positive correlation between reading books and getting high scores in the 7th grade. Here's my problem with this. What group did Melissa use to collect her data? Well, it says she surveyed them about their activities. So some probably were and some probably weren't. She found an association potentially between reading and your test score. But did she survey all 7th graders? She do a random sample of everybody in the 7th grade or 7th graders across her state or in her country? No, that's my problem here. In the 7th grade, so it's generalizing to a population that she didn't actually like sample, okay? She didn't ask all the 7th graders. She didn't ask everybody in the 7th grade. She looked at her specific class, okay? She only looked at one class. So this is overgeneralized. We have to be careful of that. The second one, the results suggest that there's a positive correlation, so I like that, between reading books and getting high scores in Melissa's class. This one I like a lot better because it narrows that focus down to people that I actually looked at, okay? We didn't do a random sample here. I didn't randomly assign like numbers and then use a random number generator or split classes up and pick a couple kids from each 7th grade class. Since we only looked at Melissa's class, we have no information on if her class is truly a random sample of 7th graders. Maybe she's in an accelerated 7th grade class. That's not a random sample. So all I know, thank you, is that we took information from her class. So I like this one. I like that one a lot. The third one, the results suggest that reading helps 7th graders achieve higher scores. What's my issue here? I'm first in line at the bus stop. Reading helps them achieve higher scores. We don't actually know that. What we're seeing here is a trend, right? The kids who did a lot of reading the week before did well on the test. I don't know what they were reading. Was it even a reading test? It doesn't say here. So I can't say that reading helped these kids do better. I just know that the kids who did a lot of reading did well on the test. And then finally, the results suggest that reading helps students in Melissa's class achieve higher scores. The other problem here is we generalize to all 7th graders. This one focuses back in on Melissa's class, but again, the reading helps. This caused this. That's not okay. So our second option is our best one here. Questions for me so far? Okay, I want you to notice I'm like nitpicking here. Like I'm going through these with a really critical eye. The more that we do these, the easier it gets to say, nope, that's saying this caused that. Throw that answer out. Nope, that's the wrong population. It said all 7th graders. They didn't look at all 7th graders. Throw that out. The more you do it, the easier this gets to spot those things that are like the out of bounds stuff that you don't want. Okay, on to the next page. We did number 5 yesterday. That was talking about different types of samples. Let's hop down to number 6. So number 6, the taste engineers at DrinkSoft have developed a new formula for their major brand, Cola Loca. They wanted to know how tasty it is to teenagers compared to the old formula. Okay, so they decided to set up a blind taste test. They randomly assigned 300 blindfolded teenage participants to 2 groups. One group was given the old formula of Cola Loca, and the other was given the new formula. Each participant was asked to fill a formula taste 10-point questionnaire where 1 is considered awful and 10 is considered delicious. The engineers found that the mean taste score for the new formula is 4 points lower than the mean taste score for the old formula. Okay, so the average for the new one was not as high as the average for the old one. They seem to prefer the old one better. That's what we're getting here. They rated the old one as tastier. What valid conclusions can you draw from the results? The old formula tastes better than the new one. That's our general gist, okay, but it's pretty broad. If we had gotten information like the old formula was always rated better than the new formula, I would be okay with that, but we got means. Remember, means are averages, okay? There's a positive correlation between drinking the old formula and the perceived tastefulness among teenagers. This, let me read that and think this kind of makes no sense, like it's a little bit of a wordy mess. Yeah, that's because it is kind of a wordy mess, right? The perceived tastefulness, like no, like does this taste good or does it not? Like we're making it too complicated. This is another common, what we call distractor answer that you're going to see on questions like this that pop up on the SAT. They're going to give you an answer that like kind of makes no sense. And you're going to spend a lot of time reading it and trying to make sense of it when really it's just not a good answer and we want to move on. Okay, this one's not good. The results suggest that the old formula tastes better among teenage boys than the new one. This one's getting closer. What's my problem here? Yeah, it says boys. Nowhere in here does it say I only tested teenage boys or that only the boys rated it higher. It just says teenagers. Let's look at our last one. The results suggest that the old formula tastes better among teenagers than the new one. That one's good. The other reason I don't like the first answer as much is that, again, we didn't limit it to our test group. Our test group was teenagers. Maybe like people over 25 like the new one better. Okay, we don't know. We didn't test them. So to say that everybody likes the new one better, I don't have the information. I didn't collect that data. I can't say that. Part B, how could the researchers modify their study to represent the taste of all Cola Loca drinkers? So this kind of leads us right into question B. We only did a study, we only did a focus group and experiment with teenagers. What could I do to expand it to everybody who might drink this soda? Do it for all ages. Yeah, do some tests with people of other ages. Do some tests with other age groups. Now, ideally, those tests would be set up the same way that this one was. So this is teenagers. So we'll say that means 13 to 19, right? Those are all our teenagers. Let's do another test then with 20 to maybe 30-year-olds, and then maybe 30 to 40-year-olds or something like that. I should be splitting up these age groups by like the whatever demographics I deem is important. I should be getting 300 of them and blindfold them and assign them randomly and have them fill out the same survey to be able to get comparable data. But yeah, if I want information on everybody who drinks my soda, I need to gather information on everybody who drinks my soda. Very good. Okay, a couple more that we're gonna look at. Go ahead and turn the page. Number 7, a researcher wanted to know if there's an association between exercise and sleep for the population of 16-year-olds in the United States. She obtained survey responses from a random sample of 2,000 United States 16-year-olds and found convincing evidence that a positive association between exercise and sleep exists. Which of the following conclusions is well supported by this data? Okay, so I'm looking at a positive association between exercise and sleep in 16-year-olds. So our first option, there's a positive association between exercise and sleep for 16-year-olds in the United States. How do we feel about this first one? Pretty good. I feel pretty good about this one too. Let's check to see if there's anything that's a little better. But I feel pretty good about that first one. There's a positive association between exercise and sleep for 16-year-olds in the world. Why not this one? I only have responses from the United States. I don't have responses from everywhere, so that's not a good option. Using exercise and sleep as defined by the study, an increase in sleep is caused by an increase of exercise for 16-year-olds in the United States. I don't like this one. Why do I not like this one? It's one kind of wordy as defined by the study. It's important to make sure that when we talk about exercise, we mean the same thing, but like they didn't define it up here for us. So why we're so concerned about the definition here is a little off-putting. There's one other thing. It's the bus stop all over again. If I'm first in line at the bus stop, I'm going to throw up at recess. Where is that in here? Caused by is the thing I have an issue with. Watch out for caused by, or this thing causes this to happen, okay? I don't know that more sleep caused them to exercise more. And if we think about it on its face, that's kind of a silly statement to make. When you sleep more, that forces you to exercise more. I don't like that. And then finally, using exercise and sleep as defined by the study, an increase in sleep is caused by an increase of exercise for 16-year-olds in the world. So again, in the world, I don't have information all over the world. I only have the information from the United States. And caused by, nope. So that first option was our best option here. Number 8, I want you to try, or actually number 8 is a little bit different format. We'll take a look at number 8 together. The CEO of a major bank wanted to assess how many of the bank's customers are satisfied. So he decided to conduct a small survey. At the time of the survey, the bank had several millions of customers across 300 branches of varying sizes. For each of the 300 branches, he picked one of the branch's customers and randomly surveyed them. Is this an appropriate way to study, an appropriate way to answer the CEO's question? So we have millions of customers. We have 300 branches of varying sizes. That means some might be really small, some might be really big. I picked a customer from each branch. So out of millions of customers, I surveyed 300. You're already shaking your head no. What do you not like about this? Yeah, this is a very small sample size comparatively, right? We've got several millions of customers. We're going to survey 300. We're taking one from each branch, even though the branches are different sizes. So already this should be sending up some flags for us. And this is probably not our best option. So is this an appropriate way to answer the CEO's question? Okay, yes, because the sample size was big enough and had obtained in an appropriate manner. Well, we just shot that down. That's not true. Okay, so let's look at what the problem is here. No, because the type of study chosen is inappropriate. So type of study means, like we did a survey here. If I want to know what people think about my bank, can I survey my customers to get that information? Sure, that's plenty appropriate. That's okay. So that's not it. No, because the study didn't have a control group and a treatment group. Well, control and treatment are when we talk about an experiment. So this would be like you are in a clinical trial for new medication. So the control group would be people who get like a placebo, and the experiment group or the treatment group would be people who get this new medication. Okay, we're not talking about something that would make sense to have a control and a treatment group here because, again, a survey was fine. So this also doesn't make sense for what we're talking about. And our last one says no, because the randomization of the sampling was flawed. That's what you guys said, right, at the very beginning, okay? We didn't get enough people. We're looking at one customer from each branch, even though the branches are different sizes. This is not an appropriate sample. That's our issue here. And then the last two practice problems that we're going to look at together for today are based on the last couple of examples that you guys saw in your notes. So we're looking at being able to take the information that we've gathered and apply it either more broadly to a bigger group of people or apply it to a sample. We're going to take data collected from a large group and say, if I have a representative sample, what would I expect? Okay. Number 9, a school has 3,000 students. A random sample of 50 students, representative of the whole school's population, is selected, and the students are asked to name their favorite athletic event. 16% of the students named basketball as their favorite. So how many students in the school would you expect to name basketball as their favorite? So we've got 3,000 people in the school. We sampled 50 students that were representative, okay? And 16% of our sample said basketball was their favorite. If this sample is representative, then I should be able to apply that percentage to the entire school population. Does that make sense? So if 16% of our sample said basketball was their favorite, then I would expect 16% of the entire student population to say that basketball is their favorite. Okay, so I'm going to find 16% of my whole school population. So that would be 3,000 times 0.16. The example in your notes was a little more complicated than this one. It was the one about like the siblings, how many siblings those 8th graders had, and we applied it to a class, and then we had to figure out how many students were in the whole of the 8th grade in the whole state. And we were then actually asking the opposite, not how many had at least 2, but how many had less than 2, something like that. So that example in your notes was a little more complicated than what we're seeing here, but this is the same big idea. I have information from a sample that is representative. I can apply it to the whole. So 16% of 3,000 would give me 480 students, okay, that I would expect in the whole school to say that basketball is their favorite sport. Now, really quickly, before we move on from this one, does this guarantee me that 480 students in the whole school have basketball as their favorite? No, okay. I'm, again, using information from a sample to make an educated, sort of an educated statement about the rest of the population. I shouldn't be shocked if it's only 463 students who list basketball as their favorite, or if it's higher than this, if it's 512, that's okay. But this gives me a good estimate, okay, a good expectation to have. Example 10, in a certain country, 12% of the 11th grade students failed a required literacy test. If 60 of the 11th grade students in this country were selected at random, how many of them would we expect to pass the literacy test? So this is really similar to the last example from your notes. We know, based on data from our whole country, all the 11th graders take this test, okay? Same thing you guys are staring at in the next like month or two, right? All the like juniors, in order to graduate high school, you guys have to take the SAT and you guys have to take that science assessment, right? So we get data on all the juniors, all the 11th grade students from our state on how well did they do. So if I then randomly picked a certain number of juniors, I should be able to guess how many of them scored at each different level that we keep track of, okay? So thing to watch out for here, it gives me the percent that failed this literacy test, but I want to know the percent that would pass. So if our fail rate is 12%, what would be our pass rate? 12% of students fail this, so what percent of students pass it? 88, yeah. I picked 60 students, so I would expect 88% of them to have passed. Now, we're going to get a decimal out of this one. We get 52.8. I want you to think about the context of your problem. In some cases, decimals make sense. Do decimals make sense in this case? No, we're talking about people, right? Can't have 0.8 of a person. Either you passed it or you didn't. So we're going to say 52. I didn't get a whole 53rd person, so we're going to say 52 students. I would have expected to have passed this literacy test. So you don't round it, you just kind of do it. The context of your problem is very important when you decide if I'm going to round up or if I'm just going to end it. So I said end it because I didn't get to that whole 53rd person. Does that make sense? Yeah. Okay. Questions for me? Okay. So hopefully questions like number 7 and number 6, those like what conclusions can I draw? Do those make a little more sense after we've done a few of them? A little easier to pick out the wrong answers. Remember, I don't want to see caused by, or I don't want to see this made this happen. Okay? I don't have information based on what we're seeing. I don't have information that I can use to say that. And I also want to make sure I'm not being too general. If I only looked at 16-year-olds in the United States, I can't say people all over the world. I didn't survey people all over the world. I surveyed 16-year-olds in the United States. Okay, so just be very careful with the wording that you're seeing.